we're talking about password cracking, we're talking about password recovery, okay? This is what takes place after a site is compromised, okay? So I'm not talking about preventing brute forcing on your website. I'm talking about after it's been compromised, what happens next. Biggest example everyone in this room knows is LinkedIn. So what we're going to talk about is how to prevent end users from shooting themselves in the foot, okay? And the way we're going to do that is we're going to laugh at them, okay? So obviously the big example, like I said, is LinkedIn. LinkedIn's randomly on a Rusted message board, a whole bunch of password hashes were posted. Me and a few friends got together, looked at it, and said, hey, these are obviously from LinkedIn. We then alerted certain people who then alerted certain people, and then it got out to the rest of you, okay? So right now, it's about 97% cracked, okay? So if you had a LinkedIn account a year and a half ago, there's a 97% chance that your password is in the wild, okay? And not you all. You all are cool. Surely that wouldn't be you. But everyone else, 97% cracked, okay? So in general, users use simple passwords, they use predictable passwords, and they have no clue at all what makes a password strong. Okay, that's fine. Well, we're the security weenies. It's our job to help them, right? That's what we're trying to do. We're trying to make an application secure. We're trying to protect our users. Okay, so the first real key point is that internet sites, and I'm talking about, random internet sites, they don't require password complexity. Okay, well, we know that, right? Random people on the internet, they don't know what a complex password is. They don't store passwords in a safe manner. And they're about a decade behind what enterprises are doing, okay? I've been a pen tester since '99, okay? And that means I break into Fortune 50, Fortune 500 companies, and I steal things. That's my job. And in the process of that, I crack passwords. And I can tell you, passwords from the internet, from sites that are compromised, are a decade behind enterprises when it comes to complexity. So we're going to say, okay, well, why is that? Well, so we know the passwords on the internet suck, right? Sorry. They do. We're not even going to talk about them. We're going to talk about what's going on in the enterprise world because I want the rest of the internet to finally catch up to what they're doing in the enterprise. So the enterprise, it's things like, it's got to be 8 characters. It's got to have certain character classes. And this is actually what OWASP recommends, and we're going to talk about that. It has to have an uppercase, it has to have a digit, it has to have a special, right? Okay? Well, enterprises also do password rotation. You got to rotate your password every 3 months. You got to rotate your password every 6 months. You can't reuse the same password, okay? Enterprises they have better hash formats. Okay? Oh, I'm a Unix box. Well, that's DES out of box. Well, I'm going to replace that with this other algorithm and bang, okay? There's some other, these are like the current defenses, okay? Some other defenses are blacklisting certain passwords. So Twitter tried this with JavaScript, right? They sat there and had a list of 500 and said you couldn't use 1, 2, 3, 4, 5, 6 as a password. Okay, so that's a defense. And obviously that's horrible, and et cetera, hour-long discussion here about why that's horrible. There's also JavaScript password meters, which is the thing you're starting to see now. You start typing in your password when you're creating a new Twitter account, and it rates you as you go. Okay, so that's another defense. These defenses have not changed, okay, in 5 or 10 years, okay? They're not. Now, more and more sites are starting to mention complexity, and they're starting to mention, or they're starting to have password meters. But why don't they go whole hog? Why don't they just say, no, that password sucks, pick a better one? You know why they don't do that? Because they're scared of their customers. If I do that and my customer says, I'm not going to use this site, I'm going to go to their competitors, they lose money, okay? These defenses haven't changed, they got to change. We need one that's designed to annoy password crackers like me. Okay, so you go along and OWASP has a recommendation Okay, and first off, one of the recommendations is on password, on password complexity. They come along and they say, okay, here's our formal recommendation. We're OWASP. We know what we're doing. It's got to be 8 characters or more. It's got to have 3 of the 4 character classes. We're going to talk about these character classes a lot. Upper, lower, special digit, ULSD. It's real important. Okay, so that is OWASP's formal thing. Now here's a teaser. I'm going to say that sucks, okay? So bear with me. Okay, so let's talk about password cracking methods, because these have changed a lot. In the last year, they've changed a lot about what you're able to do. So everyone's like, oh, you've got a supercomputer and you do naive brute force. Okay, well, that's been around for 20 years. You've got word lists. Oh, I've got lists of every country, every first name, every last name. I've downloaded every version of Wikipedia in every language possible, et cetera, et cetera. That has not changed in 20 years. We've got mangling rules, which say, hey, take the first letter, capitalize it, and add a number at the end. Okay, well, those have been around for 10 plus years. In the last 5 years, the amount of people who can do these mangling rules has grown an insane amount. I mean, there are people giving talks now that you can look up on YouTube about generating these rules based on human behavior. Okay, this is not random. This is analyzing a set of data and saying, what are these humans doing to create passwords? And then making these rules that go and do it. Now there's other methods like Markov change, which is kind of like applying statistics to letter placement. So an A is going to be near an E, but an A is very rarely going to be near a Q. Kind of stuff like that. This stuff has not changed. There's all sorts of popular tools. John the Ripper's ones, everyone knows, LawCrack, Insight Pro, Hashcat and OCL Hashcat is the latest ones. Hashcat, all the Hashcat varieties and the John ones are free, and they're amazing and they're fast. Okay, well there's newer methods. Okay, the password reuse. So I have a note to myself that says LinkedIn example. Okay, so LinkedIn occurs, we crack 97% of them. I keep them in a word list. I go on site to a pen test, right? We get a domain cached credential. So this is a cached credential from a workstation for a domain account. I go to crack it, and it cracks immediately. I'm like, sweet, because I'm going to go and try to use that on domain. That's what I do. I'm a bad guy. I look at it, and I'm like, how the heck did I crack this password? It's 11 characters. It appears to be random. How did I crack this? And I'm like, damn, I'm good. Well, as it turns out, the reason I cracked it was because I already had that plain text in one of my word lists. The word list I had it in was every cracked from LinkedIn. This was a domain administrator using their domain admin account. Their password was the same password that they had used on LinkedIn over 12 months beforehand. I got accused of cheating. And I'm like, you're mad at me. Everyone knows that LinkedIn was compromised. All my clients knew before all you all did, because I called them all. Okay? And, so anyways, password reuse. That is huge, huge, huge. I don't care if your password's random. If it's random in 20 characters, if you've used it on another site and that site didn't hash properly, guess what? I know your password. Stop reusing your passwords. Rule generation on previous data, meaning I compromised a Fortune X size company. I can generate rules at a push of a button based on their previous cracks. So when I come through the next year, I can just use those same rules that are, they're statistically generated to crack this company's websites based upon the activity, the methodologies their users use to create passwords. Because we're talking about humans. Every human in this room has a password. When I force you to change it, the likelihood that you're going to use the same mathematical idea, like, I'll put a 4 at the end, and this time I'll put a 5 at the end. Guess what? That's trivial. There's tools that do that automatically now. Okay, at a push of a button. Okay, there's all sorts of like for the LinkedIn list, like it was so obvious because so many people use the word link, linked, and LinkedIn in the password. Having your password be LinkedIn password for LinkedIn and then having your eHarmony account password be eHarmony password isn't a great idea. Okay, That's not a theoretical example, that's a real example. Okay, so the last new methodology has to do with patterns, has to do with topologies. And this is what we're here to talk about, okay? This is what we should be defending against. This is how I break passwords. This is how I do password recovery, one of my methods. And I'm going to prove that to you, okay? All right, so let's get started. Let's build a password cracking machine. I got $2,000. You can buy 3 graphics cards that you can buy at Best Buy. You can put them in a machine with a beefy power supply, and bam, you can build a machine that can crack NTLM in 3.7 days. What's NTLM? It's what every single Windows machine uses ever, and always will use. So if you've got a Windows password, in less than 4 days for $2,000, I can crack your password, guaranteed if it's 8 length. Okay, well, what about MD5? Okay, well, MD5's 8 days. What about SHA-1, which is what LinkedIn uses? 24 days. SHA-256, and then scrypt, which is what OWASP actually recommends. It would take 99 bagazillion years. That's why they recommend it. Okay, let's have a little quiz. How many sites on the internet and how many enterprises use scrypt to store their password hashes? None. Okay, so like I said, LinkedIn used SHA. They were obtained 6 months after the attack occurred. So as soon as you found out about it, it actually happened 6 months beforehand. That wasn't really publicized or put too much in the press. And to give an example, that machine that we built for $2,000, I have the equivalent of about 10 or 15 of those. So when I actually do my job, so the whole idea of, oh, that takes 8 days, no, it takes a few hours for me, okay? So we talked about MD5, okay? So MD5, we said, oh, okay, well, it takes 8 days to brute force every single 8-character password, every one of them, right? So let's see, eHarmony was hacked, right? In case you didn't know that, eHarmony is totally hacked. All their password hashes were leaked. Last.fm, they were announced the same day, actually. Last.fm slipped in after eHarmony and said, oh yeah, we were compromised too. Shh. They both used raw MD5. So if you say, well, I had an 8-character password, had an upper, lower, special digit, I'm safe. Nope, 8 days for one little machine that cost $2,000. Okay, well, my point here is that look at 9-character and 10-character and 11-character. An 11-character password is going to take 17,000 years to crack, right? No. Well, yes, but no. I'm purposely leading you down a rabbit hole here, right? So I say the bottom, I say, okay, so 9-character passwords are safe, right? I mean, you won't crack them all for 750 days. So therefore, I've proven that 9 characters is good enough and 9 characters is good enough. I'm being facetious, okay? And I'll come back to that why. I'll come back to that in a little bit, but I want to take a quick diversion, okay? Some sites don't even hash their passwords. Plaintextoffenders.com is hilarious because there's sites where you do a password reminder and they send you your bloody password in an email, which, by the way, huge security violation. B, you're not even hashing them, okay? So we can have all the recommendations in the world, but if one of our recommendations is hash your password, sites are still doing this. So this site goes and tries to offend them. Okay. So I briefly mentioned topologies, these patterns, right? I'm not going to go and brute force the entire password range. That's not what I'm going to do. Okay? If I was going up against random data, maybe I would. But guess what? Passwords aren't random. Except for the one, Unix admin in the back with the big gray beard. Yeah. His is random, okay? But no one else. Everyone's looking around like, seriously? No, everyone else is a human, and humans have to remember things, okay? So we're going to talk about these patterns, these topologies, because this is one of the keys to how humans create passwords, okay? So for instance, look at Austin 1, exclamation point, that's my town, sports 9, question mark, hip hop. You see the 4 examples, right? Okay, well those are totally different. Those are totally different passwords. Those all have the exact same pattern. It's got an uppercase, it's got 6 lowercase, it's got a number and a special, right? Okay, so that's what we're talking about, U, L, and S, and D. So, do users in an environment, do they gravitate towards certain patterns, towards certain topologies? Okay? Yes, they do. I'm going to show them to you, and then I'm going to give them to you. I'm totally skipping ahead. So why would I try to brute force the entire range? If I knew what patterns users went to, I'm just going to go after those. And I'll crack a disproportionate amount of passwords just based on these patterns, okay? So what we've done is that we've come along and, like I said, I've been pen testing since 99, 2000, and I penetrate enterprise environments with password complexity requirements. So I've been collecting cracked passwords for longer than I want to know about, okay? Well, I've analyzed them and come up with the most popular patterns, okay? So we're talking about enterprise ones, right? Okay, so here's some data. Here's a Fortune 100, right? They have 263,000 NTLM hashes. That includes password histories, right? So we found about 7,000 topologies, patterns, right? I'm not talking about words and word choice and what numbers they use. I'm talking about the pattern of how they put it in there. Upper, lower, digit, right? Okay, so that's a lot of patterns, right? Well, here's the topmost 5. So 33,000 people, or 33,000 of the hashes, 12% of the people used this, ULLLLDD. So like Denver 14. It's 8 characters. It's got 3 of the 4 character classes, right? It's a safe password. All right, I feel like the ShamWow guy. All right. So the second one down is almost the same thing, but it's a 6-letter word. It's a 7-letter word that they capitalize and put 2 numbers at the end. Okay, so you kind of get the feel here. Just looking at the examples, if nothing else. You say, hey, look at those top 5. The top 5 patterns crack 48% of the passwords in this enterprise. We're talking about half. We're talking about 5 patterns. If you take the first 100 patterns, it's 85% of the passwords are cracked. Using no word lists, using no rules, using no brute force, using no Markov chains, using no logic, except for there's these 100 patterns. Rick gave them to me. I'm going to hit enter, and guess what? I got 85% of your passwords cracked. Now, how long do you think that took to run those 100 jobs? About an hour or 2. So I'm starting to introduce, okay, the problem. Here is a graph. And don't worry about reading the numbers, just look at the pretty colors, okay? Notice how it goes to the left there, it really starts shooting up. Those are those common topologies. Okay? So what I'm going to come say here at the end is you see those topologies on the left that are super popular, super common? Let's chop them off. Let's say you can't use those. And what's going to happen? The people who are used to putting their passwords there, they're going to get distributed in these other ones. We're going to make the passwords more diverse. Okay, example 2, Fortune 500, 449,000 password hashes. That's big, okay? And that includes histories. Now, this place had 14,000 topologies, and you can see their most popular patterns over there are pretty similar to the previous example, upper, lower, digit. So the first one's like Denver 14. The second one's like Denver 14, exclamation point. The third example is kind of like 3-letter word, 1, 2, 3, 4, exclamation point, okay? Now, but look at the percentages. The most popular pattern, what was the previous example? Does anyone remember what the percentage was? 12%. What is it here? It's 4%. Which place do you think maybe has more diverse passwords? Okay? The top 5 gets 16%. The top 100 gets 62%. The other example was 85. Which one of these enterprises has better passwords? Example 2. Okay? Now it's just using one metric, but look at their graph. Does it have, on the far left, yeah, there's some that go up that are more popular or whatever. Do you think this place's passwords are more diverse or less diverse than example 1? They're more diverse because there's not gobs of people using the same one or the same sort of pattern. Okay, So we've analyzed all these topologies. And what we did was we got 8 enterprises, okay, that we were able to crack with 4,000 or more people, that we were able to crack more than 90%, right? So this is our data set. So as a reminder, this is real. This isn't sites off of last.fm and your eHarmony password. These are passwords from real places, from real humans, from people who had to meet password complexity that you all think is going to save you, okay? Not you all. You're cool. The other people. So we found all these different enterprises and different areas of business and different, I was going to say something, but I won't. They have these topologies in common. So a topology at one place that cracks 5%, if you bring it to another enterprise, it'll crack 5%. It may crack 10%. They're common. They're not unique. Well, that's good for us. That's data, okay? So this proves, since all these examples use the same topologies, because they're all humans, they're all users, it proves that this is key to how users create passwords. So here's a graph. Don't bother reading it. Look at the pretty colors. Notice how some of them shoot up really high. That's because each color is a different enterprise, a different Fortune X size company. So that one about 5 or 6 from the left there, that's the tallest. That's the most popular topology over all 8 companies. Should I allow people to pick passwords that meet that topology? No. No. It meets password complexity, but its rampant use over all enterprises it's obvious. Now what is it? So you can kind of see, so we were able to figure out, okay, which topologies are the most common, and this was all done using math. So if you look at the 6th from the left, there's a blue line. Notice how there's one and it's only blue. You know why that was? One company in particular had this one pattern that 40% of their users used because it was generated by the help desk, okay? So we actually, so to give you an example, not all your data is beautiful and pure. We actually threw that one out, but it's of interest. It's of interest to that client. Okay, so what did all this data tell us? It confirmed what we knew all along. Users pick the lowest common denominator. Well, we know that. When required to do 3 or 4 character classes, okay, well, they're gonna do an uppercase first. They're gonna put numbers at the end, and they're gonna put specials at the end. And there's whole, which special character are they gonna use, blah, 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 blah. Go Google my name on YouTube and see me talking about that. It's very boring. So if you're required to do 4 of the 4 character sets, upper, lower, special digit, there's, they're gonna put a special at the end. That we have the math that proves all this, okay? So if you go and you say the passwords have to be 12 characters, guess what your users are going to do? They're going to pick Mississippi, capitalize the M, and put a 1 at the end. You think you're making stronger passwords. You're not. You're making dumber users. No, that's not really. I don't know what you're doing, but it's not working, okay? So the bottom line there, these behavioral trends are not unique. Okay? So as soon as we implement password complexity on the internet, on all the sites, and we require the same old rules that haven't changed in 10 years, guess what's going to happen? Whoop, I went the wrong way. Ignore that. This is going to happen. The same thing's going to happen. Okay? It's not working in the enterprise. It's not going to work on the internet. Okay? So complexity rules do not work. They kind of work, but they don't work. Okay? So if your website... Okay, first off, if your website doesn't enforce complexity, you're at a disadvantage already. I was going to say something else. Okay, so you can go and obviously LinkedIn's a big example. You can Google rocku.text. It's 30 million plain text passwords from a site who's stupidly stored all their passwords in plain text in a database and then got a SQL injection compromised. You can go and Google that and you can go download them and look for your own and stuff like that. So standard enterprise password requirements does not make your users create safer passwords. I've said that 10 times now. OWASP's complexity requirements do not make stronger passwords. Okay? And that's kind of one reason I'm here. So here's just another little set of data. It's LinkedIn. So LinkedIn, you take all the cracked passwords, it has the same sort of idea where some of the topologies, are used by gobs more than other ones. And the most common one on the far left there was just 8 lowercase letters. So I like picking on LinkedIn because everyone in this room's got a LinkedIn account. It's not 13-year-olds playing League of Legends. It's people like us who know what a strong password is. It's got to be 8 characters. Yeah, well, there they are, and they're all lowercase. That's the most common one of all the LinkedIn cracks, okay? Okay, so bringing this back to OWASP. Why is it important to OWASP? Why is it important to developers? Because fix it. That's why, okay? We can't let this go on, okay? PCI points to OWASP. OWASP needs to step up to the plate, okay? And I'm a part of that too, okay? So sites that aren't doing password complexity, that's a finding in a report, okay? In my mind, that's a finding in a report, and in my mind, it should be a PCI issue, okay? If you are not doing password complexity on your website that specifically has PCI requirements, you fail in my mind because you're letting your users shoot themselves in the foot, okay? That is my opinion. So, okay, well, I'm going to implement, what are we talking about? Password complexity. Okay, I'm going to do it. I'm going to have this nice, pretty JavaScript that shows the user and teaches them as they go, and it'll work great. No, it won't. So I picked a few of them, right? So here's, password meter, and it uses JavaScript. So Denver 14, we got an 8-character password. We got 3 character classes. It goes in and says, hey, that's a pretty good password. It's got 59% out of 100. That's a good password. No, it's not. That thing would crack in 60 seconds, as would every other. You know why? Because it's upper, lower, digit, which is in the top 5 list of what everyone in this room uses. Not you, all other people. That room, okay? So, that's good? Well, okay, how about bacon 14 exclamation point? Exclamation point, first off, is the most popular special character. 14 is the current year. Bacon is something that's delicious. It's a 5-letter word that you capitalize the first letter, you added 2 numbers and a special, and oh, by the way, you use the most common special, and you use the current year. And that's a 74 out of 100? Really? No. That topology, upper, lower, digit, special, is in the top 100. It would crack in minutes. I would give that a 0%. Okay, well, here's another one. Denver 14, 15 hours to crack. Bull squat, 2 minutes. Not even 2 minutes, okay? So that's not cool, and these are the things that I just hit down and it didn't move. There we go. All right, so there's Microsoft's kind of in the top left, same thing, Denver 14, and medium. Now, Kaspersky, you type in Denver 14, you know what it comes back and it says? That would take 3 seconds, that's a widely used combination. Guess who wins? So, and there's a whole reason why they did that. It's because they're smart, okay? I don't work for Kaspersky, but I know people who do. Bam, someone's got it figured out, okay? So there's other way we can do strength meters, right? You can do them in JavaScript. You can do them in HTML5. HTML5, oh man, it's the new standard. It's secure. That's what the 5 stands for. You can go in there and in a password prompt, you can go and enforce complexity. So you don't need JavaScript. You can have it built in to the HTML. Oh, that's great. I can go in there and say it's got to be 6 characters and it's got to have an uppercase and it's got to have a lowercase. So essentially, you're whitelisting. You're saying it's got to meet these rules where I say we need to blacklist. It can't do that. Or I couldn't figure it out. You can't have a not in your regular expression. Hope maybe someone else can figure it out or whatever. So obviously, what if I'm going on my phone, it doesn't honor HTML5, then bypass it. If you do it in JavaScript, bang, I'm going to bypass it, okay? But the idea of password complexity is saying, oh, it's got to have an uppercase. That's the way it's been done for 10 or 15 years, excuse me. Okay, so here's the new HTML5. Guess what it does? Nothing new, the same thing that's been done on websites for a decade or 2. So that's not great, but this is like a current way of doing it. Okay, so why is this important? I'm stepping back a little bit. So why is this important? Password requirements are not in the OWASP top 10. Therefore, if you run a PCI website, you don't have to worry about them. You can let your users choose 1, 2, 3, 4, 5, 6, right? That's not cool. My parents use the internet. Like, I don't want them using 1, 2, 3, 4, 5, 6, or with a 7, or with an 8, you know? So the other big deal is, like I said, the enterprise idea of password complexity, it's not out there on the internet. You know, that's lame, okay? And then requiring password changes. How many sites on the internet that you use require you to change your password? None? None? None. None, right? I mean, does anyone have an example of a non-enterprise website that you go to that requires you to change your password? I'll give you $1. You know? That one, yeah. No, I mean, I'm serious. Really? Yeah, there's some banks. Yeah, banks are definitely, they're working on it, you know. Okay, so how long are we going to be afraid of our users, right? And it's great because I'm an offense consultant, so I don't really have to deal with users. So it's really easy for me to come along and say, seriously, we need to fix this. This is horrible. I don't care about the users. But then there's real people who have to deal with real customers, and they're going to like, whoa, we can't do that. So obviously, OWASP's official stance is, quote, password rotation should be required for privileged accounts within applications at a frequency of every 90 days. They probably put a period at the end. Well, okay, well, that'd be good. What's a privileged account? That's kind of vague. Anyways, I don't have a solution to this besides fix it, okay? So as auditors, as testers of web app breakers, maybe that's who some of you are, you know, what about password storage, okay? What about hash types? Okay, now this is where OWASP comes in, and they've got a great recommendation. They go in there and say any web application accessed by an OWASP-aware tester should follow the guidelines in the cheat sheet. Then they go and say use bcrypt. Okay, so they actually go in there and say, bam, you know, here's the cheat sheet. It actually is valid. Guess who follows that cheat sheet? No one. What if PCI actually had a requirement that said everyone had to do it? There'd be a shitstorm, sorry. For lack of a better word, there'd be a shitstorm, but what would be the outcome is that if LinkedIn did get compromised and their passwords were stored as bcrypt, guess how many of them would be cracked? Like 2. Like 2, not 2%, like 2, because it's that hard to crack. Sites are just using, I mean, you develop a website, oh, I'm doing WordPress, and you're just going to use their password hashing format, okay? Or I'm going to use, never mind, I was going to say something else. Okay, so the closest example I have is actually, there was a relatively small Adobe breach, and they actually used DES to actually encrypt their passwords, except for they use a static key, yada, yada, yada. LinkedIn, eHarmony, Last.fm, they all used SHA and MD5, so no one's doing this. Well, this is how you do it. I love this. This is Reddit. And they come out with a post years ago now and said, guess what? You change your password, we're storing it as bcrypt. That's kind of like holding the mic and when you're done, just dropping it, being like, what you gonna do? That's amazing. This is amazing. Not only did they do it, which would be amazing enough, they're bragging about it and coming out and being that open and honest. Who does this? No one. Oh, that made me so happy. Okay, well, here's a little bit of private data. So I'm a password cracker. You know, I'm a recovery person. There have been a lot of password leaks in the last 6 months, of which you know about 1% of them, okay? So the last 6 months of all the password leaks that have occurred, these are the most common algorithms used to hash passwords, okay? So this is real data, and there's a whole bunch of secret sauce behind it that we're not going to talk about, okay? It's not relevant. What's relevant is, what's the first one on the list? Raw MD5. 630 unique sites that were compromised in the last 6 months that use raw MD5. All right, well, where's Blowfish? It's down there. It's got 4. That's pretty good, right? No, you know. So this is real. This is real of sites that are compromised. And guess what? They use crummy hashing algorithms. Question?
Do you have any plain text just not show up in these?
Yeah, the question was, are there any plain text? Yes, there's always plain text leaks. They're actually getting less common. Yay, we're fixing things. No, we're not. There was I have to be kind of careful here. There's been an incredibly large compromise of a website recently, an incredibly large, bigger than anything you know about, and it actually used SHA-512 with an incredibly long hash. So even though the passwords are really lame, we're still only like 20% cracked because the leak is so large and the hashing algorithm is strong. So it kind of proves the point. Now, we don't know where it came from or whatever, but still, there's leaks that are out there. Okay, so I got like 10 minutes or 8 minutes. So our defenses need to evolve, okay? We can't slowly do what they're doing in enterprises and thinking that's going to work, right? Things like minimum length and minimum character set, blah, blah, blah. We still need those. I'm not knocking them. I'm totally knocking them. We still need them, but we need a way to prevent users from gravitating towards certain patterns, certain topologies. How long are we going to be complacent? Okay? How long are we going to let it go? You know? So, kind of what we've been working on is what we've been able to do on the Unix side of things was actually blacklist those common topologies. So if you want to do Denver 14, nope, sorry, that topology, that pattern, I don't care what your word is. If it's a 6-letter word, you capitalize it. You cannot do that. You can't do it. Capitalize the second letter instead of the first one. It's still kind of a lame password, but at least it's not that most common, topology. Okay? There's a lot of advanced things we can do, like don't let multiple people use the same one. We can do things like when you change your password, is your topology from your old one to your new one the same? Did you go Denver 14 to Denver 15? Because in my mind, that's the same password, okay? Prevent that. No, I'm not saying we're going to be doing this now, but when are we going to be doing it? Okay, so CoreLogic, my company, with support from DARPA, we put out something called Pathwell, which is essentially a Linux PAM module that does everything we've talked about here, okay? We haven't ported it to, web yet. But honestly, the idea is pretty trivial. It's going to be open source right now. We're still going through DARPA. So once it's implemented, your passwords will be diversified. It won't be that graph where 20% of your people are using the same pattern, okay? And then, the idea is, let's get eBay to use it. Let's roll it into our SiteMinder, our single sign-on in our Active Directory, okay? And there's all sorts of kind of like advanced things like, are we going to hint the user and say, hey, you can't use that topology, 10 other people are already using that one, that's not allowed. Well, that's a security risk. But we have to tell them why we're rejecting their password. So there's a little bit of this is not a perfect methodology, but it works, but it's not perfect. Nothing is perfect besides getting rid of passwords, right? I'm not going to go into the more advanced stuff. You can, like I said, there's other talks where we spend an hour talking about just this. But I wanted to kind of give you an idea, like, hey, we've implemented it in the Unix world, okay? Okay, so all this time I've been saying, look at all this research I did. Look at all this data. I do this. I do this. Well, guess what? Those topologies, those 100 most popular patterns, I give them away for free. So, you don't have to write down the URL. Just write down Pathwell topologies, go, bam, and you get it. You have 100 of them, okay? So that's based on my 15 years of doing this, and it's all there. I implemented something in JavaScript that blocked them, and it took me like 10 minutes, and I'm not really a developer, okay? So these are the kinds of topologies. So everything I was showing you, I just gave away for free, okay? Okay, so I have 5 minutes. I always wrap up my talks like this. You're not a special, unique snowflake. Whatever your parents told you growing up, it's not true, okay? The little trick that's in your mind that you use to remember your password, that you think, oh, no one will ever figure this out. a million other people do it, okay? And people like me are looking at that data and figuring out what you're doing, okay? The same people who do Denver 14 and Summer 13 and Fall 2004 and Password 1 with a capital P, whoo, and OWASP 2014, which is the Wi-Fi password, they all think the same thing. Oh, dude, we'll totally put a 1 at the end. No one will figure this out, right? Okay? So obviously quit doing it, but you all aren't doing it, I know. Tell your users to this, prove it to them, prevent them from falling into this trap, embarrass them if you have to. Train them into how to be, a unique little snowflake, okay? Prevent them from making simple mistakes, okay? That's it. Thanks for coming, everybody.